Hi everybody, this video today is going to cover lesson 4.2, which is characteristics of graphs. So when we talk about characteristics of graphs, we're talking about like the main parts of the graph. So for instance, origin, quadrants, x-axis, y-axis, those are words that you have heard before. I went ahead on my graph and I labeled just each, I counted by ones, so that when we go and do the coordinates, that's going to be easier. But let's also talk about origin, quadrants, x-axis, and y-axis. I think the first things we ought to talk about is the x-axis and the y-axis. So just remember the x-axis goes across and the y-axis goes up and down. The origin, that's at the middle, like where they cross each other. That place where the x and the y-axis cross each other, we call it the origin. A lot of times we use the letter O, and the coordinates for the origin are 0, 0. So it's just that point that's right there where those two intersect each other. And lastly, the quadrants. And this is one that you probably have learned before, but you might not remember. Over here, this is quadrant 1. And then we go counterclockwise, which seems a little bit backwards sometimes, but that's just what we do. And the other thing is we use Roman numerals, which is not very common these days. So this is quadrant 1, 2, 3, and 4. We just go around the loop and we go counterclockwise. All right, so let's take a look at the problems. Each of these points, A, B, C, and D, let's find the coordinates for it. So for instance, A, remember that the coordinates, the ordered pair, always goes X and then Y. That means you go across and then you go up. So for the A, that is at the point 6, 6, 6, 6. So that is point 6, 6. And the quadrant that it's in quadrant 1. Now where it says axis here, that's like if it's not in an actual quadrant and it's on the line, then there is no quadrant, it's just the axis. Okay, point B, we're going to go over 4 and down 1. So our ordered pair is 4, negative 1, and that is actually in quadrant 4. Okay, example C is over here at negative 3, positive 2, and it's in quadrant number 2. And then example D, letter D, okay, remember if you don't go anywhere, left and right, then that's a 0. And then we do go down, so we're going to put a negative on it, and it's down at negative 5. And so that is not actually in a quadrant, we just say it's on the y-axis. All right, so that's a little bit of a review of how to find order pairs and how to find the quadrant. Okay, then we have these terms, and these might be new terms to you. The term constant, increasing, and decreasing. So constant is where the graph is flat, and what is happening is the y value stays the same even when the x value changes, and we'll look at some examples on a graph. Increasing is where it's going upwards, and decreasing is where it's going downwards. You might want to pause the video here and write these definitions down. So the next several questions are going to ask us questions about these terms. So if we look at this, first of all, every time we look at a graph, we have to look at some specific things. So our x-axis is time, our y-axis is speed. And so the first part, what are the flat parts of the graph? We have a flat part here, and we have a flat part here. Well, up here we said that was a constant part. And so if I said that this is the flat parts of the graph, mean that the speed stays constant. That's like if you know about cruise control on a car, you can set a button and your car is going to stay that exact same speed. So those flat parts, that's where the cruise control is on. That means it is a constant speed. And then the next part says put a W above the sections of the graph where the speed is constant. So we're going to call this W and we're going to call this W. Okay, then circle the sections of the graph where the speed is increasing. Okay, increasing, if we look at our definition, from left to right where the graph is going upward. So I'm going to look at when I read my graph, I read it from left to right, just like I read sentences from left to right. And so here it's increasing, and here it is increasing, and here it is increasing. Those are all increasing portions. And that just means they're getting faster. And then finally it says put an X above the sections of the graph where it is decreasing. So this is decreasing and this is decreasing. that means they are slowing down in that part. And as you look at this graph, you should also notice this isn't part, this is like bonus points here. This part right here is where it got its max speed. So we don't have anything on we don't know where that is, but we know that's where the max happened. We also know that at this point here, as well as here, as well as here, that the speed was 0. They were stopped at those 3 places. Wherever it hit the axis, that's where it was stopped. Okay, so the graph that we just did had some context to it. In other words, it was talking about speed and time. Like we can imagine the car is here going faster, and then it has a constant speed, it goes really fast, it gets to the max speed, it slows down, etc. Here is a math graph, and it does not have any context to it. So we don't really know, is it speed, is it position, is it money, or anything. We just have to look at the numbers. So we're still going to use these same concepts. Where is the graph increasing? Okay, when we answer these questions, we're always answering it using the x values. And the reason for that is, like if this was time, for instance, we would say, okay, at the 1 second mark, what's going on? Or at the 3 second mark, what's going on? So again, if we think of it like in terms of seconds, for instance, where is it increasing? Well, I've highlighted these parts because that's where the graph is going up, and going up means increasing. So when it's going up, we're going to say, well, when is it going up? Well, from the point -5 to -2, that's where it is increasing. In fact, we could say that as an inequality, and maybe we should do that. If we're going to express this place in terms of an inequality with an x, because this is the x-axis, we could say that -5 is less than or equal to x is less than or equal to -2. And so that's the place, the area where the graph is increasing. It's also increasing from here to here, that is from 4 to 5. Or we could say, again, 4 is less than or equal to x, is less than or equal to 5. Okay, next question is decreasing. So from here to here, it's decreasing. But remember, we want the x values. So when we look at this, we specifically want the x values. And so we could say from -2 to 2, that's where it's going down. I always use my x values for these. From -2 to 2, it's going down. If I said that as an inequality, I would say -2 less than or equal to x less than or equal to 2. Okay, the last question here is asking us, where is it constant? Okay, constant is where it's flat, but again, we look at our x values, and if we said this as a sentence, we would just say from 2 to 4. If we said it as an inequality, we would say 2 is less than or equal to x is less than or equal to 4. Okay, let's turn the page. On this side of the page, we're going to be talking about intercepts. We have our x-intercept and our y-intercept. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. An important thing to know for this class, an important thing to remember, is when we talk about these, we always give it as a coordinate, not just a number, but an actual coordinate. So if we look at the example, remember this is our y-axis, this is our x-axis, and so right here I have my y-intercept. It's where it hits the y-axis, and that point is at the point 0, 8, and I always give it as a coordinate, not just a number. And then over here, similar, here is my x-intercept, and I give it as a coordinate, and that coordinate is 90, 0. So it's not just 90, it's a coordinate, 90, 0. So the first part says the y-intercept of this graph. Y-intercept is right here, and we could say that that coordinate is 0, 8. So we have to give it as a coordinate. And what that means, well, let's look at the whole graph. We have the distance from home in miles, and we have minutes or time. And so at 0 minutes, it was 8 miles away from home. Maybe it was a person walking home. So when we answer that question, we have to look at the axes to figure out what's going on. At the beginning, or at time equals 0, the person was 8 miles away from home. The x-intercept is over here. The coordinates of that are 90, 0. And so this time, what does that mean? Well, it means after 90 minutes, then the person was 0 miles away from home. So this graph, in the beginning, there's this sentence. The graph represents the distance from home in miles over time in x, in minutes. So when we look at our xy coordinates, that's going to be time and distance. And so as I look at this 0, 8, my time is 0, my distance is 8. I'm looking at this right here. Time is 0, distance is 8. And if I look at the other coordinate, my time is 90 and my distance is 0. So after 90 minutes, that's the time, they're 0 miles away from home. Okay, let's look at another example. All right, once again, we have to read the graph and read the sentence. The graph represents the height of a diver versus the time after the diver jumps from a springboard. Answer the following questions based on the information. So over here we have height in meters, and then we have time in seconds. Okay, that's a really tall, that's a really tall springboard. So like when you go to the pool, there's like the 1 meter dive is the low one, and the 3 meter dive is the higher dive. So this is 24 meters. That is super high. That's like on the Olympics when there was big platforms. It's really high. I can't believe there would be a springboard that is that tall. That's really tall. Okay, the y-intercept of the graph is here. That's what we've been talking about. Looks to me, man, it's hard to read, isn't it? I'm going to say 24 meters. So the y-intercept, we always start with a 0, and then we say 24, because remember we have x and then y. So the y is the 24. Okay, x and y. X is the time, and y is the meters, or the height. So if I have this, 0 is my time, 24 is my height. So in context, this means that we could say the diver starts at 24 meters. That is super high. That's like a 7 or 8 story building. That's how tall that is. Okay, next question. The x-intercept, that's over here, and it looks like it's about 3.5. And again, we always give it as a coordinate, so 3.50. And the first number is the time, the second number is the meters. So in context, this means that at 3.5 seconds, the diver's height is 0 meters. In other words, they hit the water. All right, we will do some more examples like this in class where we have some context and we're talking about what's happening in context.